Hey, this is Mr. Weisfeld. We're talking about waves in time and space. Two questions, number 13, multiple choice number 13 and number 14 on page 414 in chapter 11 of Hecht. I've got the typical displacement here, but notice that along my, what would be the x-axis, horizontal axis, I've got time. What you should be thinking about is, as time goes on, I'm watching a point in space change its displacement. So imagine that here's a wave, and I've got, this is now displacement versus distance. So a wave we've seen can travel something like this. Have a certain shape in space at any given time. Now what we're going to do is, for these graphs, imagine that you've picked a point on the graph, like here. You're at a certain point in space. You're a fixed point in space. And you're going to watch that fixed point in space as time goes by. So now you're sitting on this point here, and you find yourself going at time 0. You're kind of on your way up. And then as time goes on, you're on your way down again, and then you're down in a valley again, and then lo and behold, over a certain period of time, you find yourself just going up and down. It does not make sense to say this wave is traveling this way. That's kind of bogus, because that's just the increasing time direction. It doesn't really make any sense to say the wave is traveling the other way either. That doesn't make any sense either. So the point is, what you're looking at is the time history of a certain point in space. So let that sink in for a second, and we'll use it to think about this wave here. So figure MC13 depicts the displacement of a particle in a medium plotted against time as a wave propagates through. So notice, if this is the motion of a particle versus time, you can conclude that this particle is being influenced by a wave. Notice the power of that statement right here. Did I see the wave? No. Do I know what the wave looks like? Do I know the wavelength of the wave? Do I know anything about that wave? Not necessarily. Wavelength is a space relationship, and this is about time and amplitude. It's not necessarily about how this wave looks in space. So keep track of that for a second. The period of this wave, so remember that period, t, period, is the time between cycles. In other words, it's seconds per cycle. Remember that frequency is 1 over that, which equals cycles per second. We'll deal with both of those, of course, but let's first think about what the period of this wave is. Let's get a different color here. Let's talk about green. So any point on this wave shape, that is doing the same thing, that's at the same point in a cycle, that's repeating over and over again, can be considered not a wavelength now, technically, because it's time again, but it can be considered the period now. So we're measuring period because we have time on this axis. So the period of this wave is from point 1 to point 5. So the period is 0.5 minus 0.1, all second. So that equals 0.4 seconds. That's the time it takes. Now, any 2 points on the wave that are doing the same thing will be 0.4 seconds apart. So 1, 0.1, 0.2, 0.3, 0.4 from A to B. or 0.2 to 0.6, and likewise these valleys are also 0.4 apart. So 0.4 seconds, the answer is D, is the period. Then the displacement of a particle, again, figure on the displacement of a particle in a medium plotted against time as a wave propagates through. Remember, we know that this particle is being influenced by a wave, Didn't finish that sentence, okay? The frequency of this wave, so frequency is 1 over the period. We know that that's frequency is cycles per second. If I know that one cycle, this is seconds per cycle. If I know that 1 over 0.4 seconds is now going to give me 1 over seconds per cycle, so cycles per second, that is basically 4 divided by 10, or 2 into 5, 2.5 hertz. So 2.5 hertz, A. So 2.5 peaks go past me. Yeah, 2.5 peaks go past, well, actually 1, 2, 3. The third one comes by and a half in a second, and that seems consistent with how this is being measured here, because we basically said that every 0.4 seconds I'm going up and down, or I have gone down, I've gone up. I've started from the topmost point, gone down, and then come back up again at 0.4 seconds. That makes sense. So it's 2.5 cycles per second. So those are the solutions, and that's some of the discussion for these questions. Thanks for listening.